Are you in search of key questions on chemistry and research? In this video, we'll analyze all what you need to understand about that. And these videos will be in different units. That's why you need to subscribe so that you receive them as they are being released. The electronic configuration of 5 elements represented by the letters P, Q, R, S, and T are indicated below. We have PQ to S, and you can see here that what we were given in SPDF form. That is the what sub energy levels form. So to get our answer in this very question, we have to change it back to what? To KLMN. That is what? That is the energy level of that very atom. Then the first thing we are going to do now to understand it is to quickly label this very atom that you can see here. Atom you can see here. So we understand the structure, then we'll be able to solve this very question correctly. In this very condensed part, we have proton there, we have neutron there. That is actually what we call the nucleus of an atom. The nucleus of what? Of an atom. That is the nucleus. Then we also have this very circle you can see here to be what? To be the electron. It revolves around the what? The atom. The nucleus in an atom. You understand? So we also have what? We also have this very line you can see here as the what? As an higher energy level. This one is an higher energy level. And you could call it shell as well. Higher energy level. And this second one is what? Is a lower energy level, or you could call it the what? The lower shell as well. So there's a tendency for an atom that is in the higher energy level to drop to what? To the lower energy level, and that is what we mean by ground state and excited state. In this form, an electron that has energy can be excited from the lower energy level to the what? To the higher energy level. Why an electron that what? That loses energy can be what? Can be brought back to the ground state. That is the lower energy level from the higher energy level. So that's just the scope of it, and as we move on, we'll be able to understand many stuff. And we're talking about this electron. They are kept in orbit around the nucleus because of what? Because of the impact of the proton. Because proton is positively charged, so electrons will be negatively charged. So they'll be able to balance themselves. And at the same time, understand this: the proton is kept in place. Just imagine you have proton, a lot of proton in a circle inside the same place, in a condensed place. How is it possible for this proton to what? To stay there and to still be rigid and the likes? It is because of the strong nuclear force as experienced by the proton. Here, the neutrons would bind the protons together so that they will not what? So that the nucleus will be what? Will be a stable nuclei. Generally, this energy level, which you can also call the what? The shell, are indicated with n equals to 1, n equals to 2, 3, 4, and the likes. When you have n equals to 1, that shows that what? That's K. When you have n equals to 2, that's what? That's L. When you have n equals to 3, that's what? That's M. When you have n 4, that's N. And when you have 5, that's what? KLMNO. So like that, it progresses like that. And if you want to know the maximum number of electrons that can be found in each shells, then you have to understand this very formula. That's what? Shell. That's 2n squared. That is what? If it is when n equals to 1, that's K. You have what? You have 2 into bracket 1 square, and that will give you what? That will give you 2. So the maximum number of electrons that you can see in K will be what? Will be 2. And we are talking about the second one as well. When n equals to 2, that will give you what? That will give you 2 times 2 square. So 2 times 2 square. 2 square is what? 4. So if you multiply this, you will get what? You will get 8 as your final. Since we've understood this, let's really move to the question. When we're talking about P, you will see that what? We have 2, 2, 2. These are the electrons. These are the electrons. We have 2 here. That's the indication of the electron. The electrons. So you can see that generally we have what? We have 6 here, right? So grouping them according to what we have here, you would realize that what? They can be grouped into K has a maximum number of what? Of 2 electrons. Would have a maximum number of 2 electrons. Then comma, you check L has a maximum number of what? 8. So you can quickly write the rest, 2, 4. So that's the electronic configuration of that very first one. And the second one, let's check. If you check the second one is not 6. The second one is what? 8. Then if you look at it, that will be 2, 6. Then this one also, the third one will be what? The third one is 10. So that will be what? That will be 2, what? 8. That is the real gas I was talking about. And if you look at this, we have 2, 2, 6, 2. That is what? That is, we have that to be 12, where we have 2, 8, 2. That shows that is our group 2 element. Then we have the last one. Yeah, that is what? You check it, that is 15. We have 15. So that will give us what? That will give us 2 into bracket 8 into bracket 5. Moving to the questions. This is how they group them. Now talking about the number of electrons that is in the outermost shell of that very atom. That is how they group them. Group 1 would have just 1 electron in its outermost shell. That is the highest energy level it has in that element. So when I'm talking about the second one as well, group 2 would have 2 electrons. Group 3 would have 3 electrons outside. Group 4 will have 4 electrons outside. Group 5 will have 5 until you get to group 7, which has 7 also, and you get to group 0, which has 8. So without identifying the elements, state which of them belongs to number. That's number 1. Belongs to group 6 in the periodic table. I'm talking about this. You should know that what the answer should be Q, because Q has what? Q has 6 electrons in its outermost shell. So we have that to be what? We have the answer of this to be Q. Then how about II? But if we were told to actually name these very elements, to identify these very elements, the element of P, the element Q is what? We have Q to be an oxygen. You understand? So we are talking about the second one as well. That is strongly metallic in character. Now I need to talk about this. If you have when we're talking about chemical combination, we have 2 types. We have electrovalent or ionic combination, or the second one, that is covalent combination. Covalent involves sharing, while electrovalent involves the what? The losing and the receiving of electrons. It could be an electron, it could be electrons. So the one that would give out electron, it is a metal. It's called a metal. And the one that would what? That would accept that very electron would be the non-metal. Generally, group 1 element, that's what? Alkaline metal, and group 2 agallic metal. Group 2 elements, alkaline earth metal, they are what? They are very, very metallic. So, and it increases like that. Group 1 has higher metallic property than group 2, just like that. And we're also coming from group 7 parts. Group 7 has a higher non-metallic property. Group 6 has a lower non-metallic particle and the likes. So just like that, from 1 to 2, like that, they have strong metallic, while the 7, 6 and like, they have what? They have strong non-metallic, because they are the ones that accept these very electrons. So looking at our diagram so that we can understand this chemical combination, we are talking about the electrovalent combination. If you see, we have sodium atom and we also have chlorine atom. So sodium atom has just only one electron in its outermost shell, making it, that means it's a what? It's a alkalic metal. So for you to understand, this very alkalic metal would send the only one electron that it has in the outermost shell to what? To this very chlorine atom. Will send with that one atom so that it can what? It can form an octet structure. And also this very chlorine that has 7, so that 7 can be turned to 8 and it could be an octet structure also. The chlorine will receive 1 as well, so making chlorine a non-metal. Just like I said, group 1 element, is strongly metallic. So if you check this, we don't have group 1 element, but we also have group 2 element. That is what? That is another one that is strongly metallic but not as metallic as the group 1 element. So we can therefore pick group 2 because group 1 is not here. So the answer to this very question will be S. To pick S as the answer. Then talking about this very third one as well, readily ionizes by gaining 1 electron. What did I say about gaining 1 electron? I said that if you gain electron, that means you are a non-metal. So they're just trying to refer you to a non-metal that is in group 7, because it is only group 7 element that can readily ionize with just only 1 electron. Instead of 5, this should be actually 7. So let me quickly put that as 7. So that is the group 7 element I was talking about. So the answer to this very question will be C. Question number 4. State which of them contains 2 unpaired electrons in the ground state atom. To enjoy this, you have to start by talking about the ground state. So this indicates the nucleus. Then we also have an energy level here. So we also have another energy level. We could also try to put another energy level there, making 3, right? So that will be KLM. You understand? So the first one is K, right? So that one has lower energy level to M, and it also has lower energy level to what? To N. So this is K, this is L, this is M. So now talking about the ground state here, we are going to look at all these elements we were given here, P, Q, R, and all that. If you look at them, you see that what? There's only 2. Only this P. It's only this P. It's only this P, Q, and R. That is what? That has lower energy level than others. I'm talking about S now. S has M. It has M, that's 2. It has, and T also has M to be 7. So that means we will not deal with S and T at all. You understand? So what we have issue with now is P, Q, and R. To understand the one that has what? The one that contains 2 unpaired electrons in the what? Ground state atom. So that means P, Q, R in this very question is the ground state atom. Starting from the scratch, we have S to contain what? To contain 1 orbital, and it what? It contains 2 electrons. We have P to have 3 orbitals, and it contains 6 electrons. We have what? We have D to have what? To have 5 orbitals, and it contains what? It contains 10 electrons. And we also have F to have what? To have 14 orbitals, and it contains what? It contains 7 orbitals, and it contains 14 electrons. Just know that I'm talking about orbitals and electron relationship. Orbital would have, if orbital is X, electrons that will fill that orbital will be what? Will be 2x, just like that. And I'm talking about how they increase. S has 2, 6 as P as 6. That is telling you that what? It increases by 4. Now, going to the filling of these very orbitals, we have what? We have things to understand. There is a law that is governing this thing. An orbital would occupy two what? 2 electrons, just like I said earlier. So this very one s2 now, we have one s2 as P here, right? And that is what we are trying to bring out here. So one s2 is 2, right? So you fill this first, the first spin, then the second spin. Then how about 2s2 as well? It is just one orbital, so you fill this as well, and you fill this as well. So it has 2 electrons like that. That's 2s2. Then we'll move to 2p. 2p has what? Just only 2 electrons here. So that means that we just fill, because we'll start by filling it first with one spin. Then later we'll come back to fill the what? The opposite spin. So the first one is 1. Then we'll fill the second one also 2. So we fill the second orbital, and the electrons, we are no more electrons to fill again. So we'll leave that like that. So this one has just only 2 unpaired electrons. Do you understand it now? Let me quickly do the Q as well. If you look at Q has what? 1s2, right? So the first spin, the second spin. Now the second 2s as well. The first spin, the second spin. Now moving to 2p. 2p has what? 4 electrons, right? So you finish. You first you give them one spin before you try to give them the second spin. So that will be 3. Then we have 4. So this one as well has just only 2 what? 2 unpaired electrons, because we have it here, just like you can see here. So now let's move to the last one as well. The last one has what? The last one is R. R has what? R has 1s2, right? So in this 1s2, if you want to go about that 1s2, you write 2 spin there. 2s2 also has what? 2 spin. Then how about 2p6? 2p6, you fill the first electron here, second electron here, that's 2, 3. Then you would what? Start to fill the opposite spin. The first one, the second one, then we have the third one, that's 6. This means all the electrons here are what? Are paired. To understand it very well, I would advise you to solve S and R and tell me the answer in the comment section. And you also need to understand this very part. We have this very symbol Q, then you have X here, you have Y here. That X means what? Means the mass number, or the what? The atomic mass. Y here means the what? The atomic number. That's the number of proton. But the mass number is what? Is the number of proton and the plus the neutron. But we are talking about electron. Electron to a neutral atom is the same thing as proton. But if you have ion on it, that means you subtract it from that very ion. If it's an anion or cation, so you look at it very, very well. So let's move to the next question. Question number 5. Which of them readily loses 2 electrons during chemical bonding? That will be S. You see, it has what? It has only 2 electrons in its outermost shell. So it's a metal. To lose that very 2 to a non-metal. So we have S to be the answer to this very question as well. Then let's look at, okay, I did not even write it. IV, the answer to IV is P and Q. P and Q, because they both have 2 unpaired electrons in their ground state. Then the 6th question as well. Which of them does not participate readily in a chemical reaction? That is what? That is neon. That is the neon, the one I was talking about, that neon. That is R. R as what? R as actually obtain an octet structure. So they seldomly react. if you look at them very well, that was even the reason why they gave them group 0, like I said before. No bonding electron at all for them to react with other elements. So the answer to this very question is what? The answer is R. Now, the last question in this part before we move to the second part, that is an S block element. Talking about an S block element, they are generally group 1 elements and group 2 elements. Talking about the others like 3, 4, 5, 6, 7, 0, they are what? They are actually P block. Why they are this group 1 and group 2 is what? We have them to be S block elements. So in this very question, it's even clear. Even if you don't know that, you should know that what with the with these 2s2 that you see here, 3s2 that you see here, the answer should be what? The answer should be S. For Unit 2 and other related videos, don't forget to check the description section and also subscribe to this very channel for more videos. Bye for now.